Okay, this next video we're going to talk about congruent versus similar. Congruent triangles or congruent shapes versus similar shapes. And we can have these apply to more than just triangles. Remember, congruent has to be equal. If congruent is equal, congruent means that you're going to have the same shape and the same size. Because to be congruent, all angles, corresponding angles, must be equal. Corresponding angles are equal or congruent, and corresponding sides are congruent. Okay, corresponding angles and corresponding sides are equal or congruent. So now, let's look at a picture of these. If I can draw it pretty good here, there's one. And even if they're not exactly the same, this is A, B, C, and D, E, F. What we have here is angle A is congruent to angle D. Angle A corresponds to angle D. Angle B is congruent to angle C, E. So angle B is corresponding to angle E. Angle C, notice I put 3 hatch marks in this one. Angle C is corresponding to angle F, and angle C is congruent to angle F. Therefore, triangle ABC is congruent to triangle DEF. And notice when I write that, triangle ABC is congruent to, I think congruent is written that way, DEF. And notice the order on this. Did I get outside of vision? Almost. Okay. Let's move this in just a touch. A, B, C. Notice that they're written in the same order of corresponding. A corresponds to D, so they both have to be first. B corresponds to E, so they're second. And C corresponds to F, so they're third. Corresponding angles have to line up to each other. What this means as well is this is equal to this one is equal to this one, and this line is equal to this line. So we have AB is congruent to DE, BC is congruent to EF, and AC is congruent to DF. Okay, so that is what congruency is. So now let's look at similar. Similar is not the same shape and same size. Similar is the same shape, not the same size. But corresponding sides must be proportional. Okay? So, congruent versus similar. Not the same size, but the same shape. So, if I can do this and get this drawn the same, there would be one triangle. Not perfect, but pretty close. This triangle and this triangle have the same shape. And what that means is that the angles have to be the same. So angle A, let's try different letters. How about D, E, F again, okay? Angle A is congruent to angle D, angle B is congruent to angle E, and angle C is congruent to angle F. Therefore, because the angles are all the same measurement, they're congruent, corresponding angles are congruent, therefore, this would be same shape, but not the same size, thus making these similar right triangles, similar triangles. So, the thing about similar triangles is we can use similar triangles to do a lot of different calculations. So let's first look at what it's like to use similar triangles to calculate things. Okay, let's do this. Okay, A, B, C, A, D, E. Okay. These two triangles are similar to each other. I have parallel lines over here, so therefore that's going to make them similar to each other. Now, we can prove this similarity, and we'll go into that later. But the first thing to understand about similar triangles is that corresponding sides must be proportional. So if I say that AB is equal to 10 and AC, which is from here to here, is equal to 15, and if I give this a measure of 12 for A to D, then I can calculate what A to E is, okay? So in other words, since this corresponds to this one has to correspond to this one in the same ratio. And if you've taken 100 with me, you know how to set up these proportions. So let's set the smaller triangle to the bigger triangle. So 10 to 15, because side AB corresponds to side AC, has to equal, my smaller triangle is 12, and my larger triangle is the one I don't know, so I'm going to give it the variable x. So now all I have to do is do cross products to solve this. 10x is equal to 15 times 12, and so divide by 10 on both sides, and x is going to equal, well, let's take, let's go 5 into that is 3, 5 into 10 is 2, 2 goes into this 6 times, that gives me 1 on the bottom, and 3 times 6 is 18, therefore, side AE is equal to 18. So we can figure out what is missing and find the other distance. These things work really well for calculating things that we don't know for sure. So let's look at another example of this. Okay, I have a big tree. And I don't know the height of that tree, but I know when the sun is shining, it casts a shadow that is 60 feet long, okay? Now, I want to know how tall is this tree? The height of the tree is my question mark. So I'm going to take a pole that I know the measurement of. Let's say my pole is 6 feet tall. And I'm going to put that pole in where the shadow of the pole matches the shadow of my tree. And I'm going to measure from this pole spot to the tree, and I'm going to get 8 feet, okay? Now this line could be continued up there, not that that's important for right now. Now, I've got a big triangle that has 60 is in relationship to my 8, and then I've got a smaller triangle of my tree in relationship to my 6 feet. And I'm going to have to move this a bit because I see that I'm off my screen, so we'll make this a little bit smaller here, so it'll make more sense. Okay, 8 feet and 6 feet. Hopefully we can see that now. Yes, we can. Okay, so we're going to compare my tree to my 6 feet, which is my unknown to my 6 feet. And since I did my tree, I'm going to have to do my big shadow of my tree. It's going to be my 60 feet to 8 feet. Okay, now again, cross products. And I'm going to have 8x is equal to 6 times 60 and divide by 8. So I have x is equal to, well, let's see. 4 goes into 8 2 times, 4 goes into 61 15 times, 2 goes into 6 3 times, and 2 goes into 2 1 time, giving me 3 times 15 is 45 over 1. So therefore my tree is 45 feet tall. So you can see how you can use your similar triangles to find the measures of sides that you do not know what they are. And it's a really good way to do that. Okay, now we're going to look at comparing two triangles that are to tell if a set of two triangles are congruent or not. And we actually have 3 ways to do that. So let's get this erased. Let me check my time first on this one. 12:11. I better start a new video for it. Okay, don't want to overdo my time.